Hello and welcome to Statistically Significant. In this session I will be discussing the two-way analysis of variance. In my first video I had discussed the one-way ANOVA using this MS Excel, and in this session I will be discussing the two-way ANOVA. So let's have a look at the problem here. Here we are given a table where the ratings of the service stations are given, and these are the raters, the capital A, B, C, D, they are the raters, and we have the 10 service stations. These numerical values are the ratings given by the raters to these service stations. Now, why are we using the two-way ANOVA here? It is a question. See, the ratings are affected by two factors. Factor 1 is the raters, these 5 raters, and the 10 service stations. So our response is affected by two factors, and that is why we are using the two-way ANOVA here. And now for the testing part, what should be my null hypothesis? As it's a two-way ANOVA, we have two null hypotheses. The first is that there is no significant effect due to the raters. Against the first alternative, there is a significant effect due to the raters. Our second null hypothesis is that there is no significant effect due to the service stations. Against the second alternative, there is a significant effect due to the service stations. So now moving on to the calculation part, we will be using the MS Excel's data analysis package. So now we go to data analysis and we use the ANOVA two-factor without replication. Now why without replication? See here, corresponding to the first rater and the first service corresponding to the first rater and first service station, sorry for the audio, we have just one value. There is no replication. Now it is not a good thing, because when we have replication we get a better idea about the nature of the variables, but as in this case we have just one value, that is there is no replication, we have to use the ANOVA two-factor without replication. For the replication part I will be making a next video on this topic. So now going on to the ANOVA two-factor without replication. So we select our input range, same as for the one-way ANOVA. Our input range is this, we select like this. Yes, and labels, yes, we have labels. These are the raters, they are the service stations. We have the labels in our input range. The output range is this, sorry, this typo, yes, and now that's it, we get the values. Now the interpretation part. See, the summary table is not that much of use, it's okay, but now we come to the ANOVA table. Here the rows are the raters, the capital A, B, C, D, and the columns are the service station, the small a, b, c, d up to j. The SS means the sum of squares, DF is the degrees of freedom, and MS is the mean sum of squares, which is obtained by dividing the sum of squares by their corresponding DFs. Now why it is 4? See, we have 5 rows here, A, B, C, D, E. So it's 5 minus 1, 4. We have 10 columns, A to J, that's 10 minus 1, 9. Total we have 50 values here. See, 5 into 10, 50 values in this table. So 50 minus 1 gives 49. Now 49 minus 9 plus 4 gives 36. That's for the error part. That's the DF for the error. So now coming to the interpretation, F stands for the F statistic. Here it's the F ratio, which is the MS rows divided by the MS error, and here we get the value 1.15, which is less than the F critical value 2.6. So when the observed value is less than the critical value, we fail to reject the null. Yes, we cannot reject the null in that case, we have to accept the null in that case, and we therefore from the comparing the F observed value with the F critical value, we conclude that yes, we have to accept the null hypothesis that there is no significant effect due to the raters on the ratings. Now coming to this F value, it's the MS columns divided by the MSE, that's the MS error, and the observed value is 9.209, which is much greater than the F critical value 2.15. These critical values are obtained from the statistical tables. Excel generates them from them, it's developed within Excel. So now this F observed value is much greater than the F critical value. Then in that case we have to reject the second null hypothesis, that is yes, and we have to accept the second alternative hypothesis, that is yes, there is a significant effect due to the service stations. Now we can also do the interpretation with the help of the p-value. See, we have taken our alpha to be 0.05, our level of significance is 0.05. So for the rows, that is for the raters, the professional raters, the p-value is 0.34, which is greater than 0.05. So we fail to reject the null and we accept the null, that yes, there is no significant effect due to the raters. And for these columns, that is for the service stations, the p-value is much less than 0.05. So we have to reject the null, because the lesser the value of the p-value, the greater the evidence of rejection the null hypothesis. So from this p-value we said that yes, there is a significant effect due to the service station, and we reject the second null hypothesis. That's it from ANOVA 2A. For the ANOVA 2A replication, stay tuned to this channel. Do like, subscribe and share.